programs, I'm going to share a little bit about what we've learned at Cornell Tech through developing a K-5 scope and sequence at a specific school that we've worked with. Because I think that those of you who are interested in getting involved in the elementary space and partnering with schools should be aware of some of the things that we've learned. So first, hello everyone. My name's Meg Ray, if you don't know me. I'm an ed consultant. I do educational research in CS Ed, curriculum design, teaching CS Ed courses, and I'm a coach and PD provider for teachers. Okay, so we're just gonna dive right in because there's not much time. This is a draft, it's an in-process document that has our curriculum map. This is a result, I'll give you the context in just a moment, but let me just walk you through this. This is a K-5 plan for year-round computer science at a specific school. We will return to this when you have more context, but I just want to show you what we're doing and what I mean when I say a curriculum map or a scope and sequence. So here's the context. This school has a school-wide implementation, and they are currently in their 4th year of that implementation. What that means is that there are 2 periods of computer science taught every week by the regular classroom teacher. And in order to pull this off, the principal has really made it part of the school culture. It's an expectation of every teacher, and it's part of the school's daily life. The teachers receive a full day of PD followed by 6 one-hour PDs throughout the school year each year. They receive ongoing coaching at least 1 day a week from a coach who's in the classrooms. They have some time for grade team coordination and planning, and all of this is made possible by a university partnership with Cornell Tech, as well as some DOE funding from New York City. So our process to develop this was, we started with, they were in a NYC DOE program that provided them with a sequence of lessons to do throughout the year. And they also, the school district purchased specific devices for this school as part of the program. So that was the starting point. Then through their partnership with Cornell Tech, we placed what we call a teacher in residence, which is our fancy name for a coach. And we placed one of those in their school. I'm trying to open the chat. So that started out being me, and I just saw their current coach, Liz, drop into this. So she's here as well. Yeah, it is the PD is a very nice luxury. This is part of the commitment of the school. They've given us their required hour after school on Mondays 6 times throughout the year. So that was part of the administration's commitment. So we started with this framework given by the DOE. The coach worked with teachers to co-develop units and lessons that started with what was provided and sort of mashed up and brought in other resources. And then once we had a sequence, we had to keep iterating on it. And we did that collaboratively with teachers and the coach. We never went in and said, this is what you're teaching. Through the iterations, we've aligned better with CSTA standards. We brought in what at Cornell Tech we call rigor and joy, which is our measuring stick for all CS education. And the teachers started planning and adding subject integration, meaning in addition to their CS units, they're integrating CS or CT into other periods of class. And this is ongoing. It just, we are learning so much that this will never be set in stone, at least as far as we can tell. And Hang on. Okay, can you still hear me? Great. Okay, so I wanted to just share some of the things that we've discovered that have been interesting to us. And I want to emphasize that these are not research-based. Cornell Tech is conducting research on this work, but what I'm sharing today is just our insights from our experience with the school because we think it can be helpful. So one of our biggest insights is that we really don't know what kids can do when they've had several years of CS instruction. We always go in assuming every child is a beginner, but now we're teaching young children who are not beginners, and they keep surprising us. So for example, we were using the robot mouse in kindergarten, and they were there's buttons on the back of the mouse, which makes it less abstract than coding in an app and making the robot over here go, right? The buttons are actually literally on the robot's back, and it can follow directions, directional instructions. Well, after we had already implemented that in kindergarten and first grade, we added on preschool, and we found that in pre-K, they were able to move from coding each other and coding with pen and paper, followed by creating pseudocode, and then the teacher moving Cubetto following their pseudocode, to them coding Cubetto on a small portion of the mat, to them using the entire mat and coding Cubetto on this separate device and using the function block. That is a level of abstraction that we were not going to attempt to teach preschoolers or kindergartners or first graders. Once we realized that the pre-K can do this, we realized we have to rethink kindergarten and first grade. That's not reflected in the current version. Another thing we have to rethink, we were using the Scratch Junior curriculum, which says it's for grades K to 2. So they were doing this up through second grade. And starting a couple years ago, we started with what in New York City is called the gifted and talented class. They've tested into a more advanced class. That teacher came to me and said, I think they need Scratch. So first we moved that class onto Scratch. Once they did that, the other teachers came to me and said, I think our students are ready for this too. They've already done Scratch Junior for 2 years. So these are the assignments that our second graders do towards the end of the school year in Scratch. Music machine and a teacher-made ELA integration. And they specifically have remixed materials from Code It, which is an amazing elementary school resource for Scratch. Okay, and then another surprise. This is from not this school year, but last school year. We added in microbits. We were so excited to add in more hands-on work. So 5th grade was actually scheduled to make a micro pet. You can see the extent of the code they would be using in the 5th grade micro pet. At the same time, their technology teacher had received Raspberry Pi training and created a basic Raspberry Pi unit about communication and signals in engineering. And so we had 5th graders working on this project that you see here at the same time that we realized every single 5th grade class, including the classes that were primarily English language learners and the classes with high amounts of students with IEPs, were able to complete this unit at the same time. And they used Python. So they just built basic traffic lights. They changed lights on a hat. So they did different things, but they really surprised us. And so we have to rethink moving forward the order of some of these. I think microbit will stay in 5th grade, but we may do it sooner to prepare them for this. The other things that we've learned are that all really means all in the school. So the self-contained class in the school does computer science. Their focus is on social emotional learning, and they've had great success using robots to help students learn social skills. Of course, it's in inclusive classrooms, but what we've realized is that different types of groupings are really important. So we've had students with significant disabilities who are able to like participate and be part of a project, a group project, in a way that they were not able to do, or maybe other students weren't letting them do in other subject areas. At the same time, it's also good to pair students of a similar level so that they're challenging each other. And finally, we also, like I said, this school has an advanced program that kids test into. And we found that those students particularly needed computational thinking skills related to persistence, related to tinkering and debugging. Those are things that we think of as sort of, we introduced those in kindergarten, but those kids needed that flexible thinking and those problem solving strategies. I think, how am I doing on time, Diane? Okay, good. So I'll zip through the teachers. So this could not have been done without the buy-in and dedication and hard work of all of the teachers. The teachers at this school have really, they are the ones who have developed this curriculum map with guidance from a coach, but they're the ones who've done the hard work, who've come up with a lot of the ideas, and who have done the work to write it out into lesson plans and create materials to go with it. And a part of our program at Cornell Tech is focusing on building agency in teachers in CS so that they identify as a CS teacher. So takeaways from working with the teachers for 4 years is that it really does take time for teachers to build the skill to be able to integrate CS into a subject area. That's something we all want teachers to do. But it took till year 3 for the teachers to be comfortable co-developing math integration with the coach. Now in year 4, I think that they're doing it on their own. I will say that it takes even more time to build confidence. Once we noticed that teachers were like really proficient, able to make their own lessons, doing well, even after 4 years of experience, many of them don't feel like that's the case. They're creating excellent lessons and saying, oh, I'm so horrible at this, I have no idea about CS. So the confidence piece actually has been coming later than the actual skills. We started out using code.org for a big chunk of the year. And now we've pared it down so that it's at the beginning of the year. We see code.org as our explicit teaching opportunity. In addition to allowing us to do some explicit instruction, it's a scaffolding piece for teachers as they start out. When they're brand new to CS, they learn from code.org as they teach, and they have a framework that is guiding them. Once they gain experience and again, agency, we cut back on that because we want to see more project-based learning. We want to see inquiry-based activities. We want to see them using some of the research-based pedagogy like PRIM. Now this takes more time for teachers to develop. That's why we start them, they started out half the year code.org, right? And now they do it about a month to a month and a half. And it will probably stay because like I said, it has that, it's that direct instruction piece. And then they build off of it and create these rich learning experiences through projects. We have implemented universal design for learning, school-wide training with varying results. We've found that, you know, teachers, we already know teachers are completely overloaded cognitively with teaching a new subject. When we try to bring in equity strategies like UDL, it's just a bridge too far. So our team is currently thinking about how do we bring this in without overwhelming teachers. And we are just starting to find out what it means for having a whole group of teachers who have taught CS for 4 years. We know that they look way different, and we're starting to analyze our data on this so that we can publish about it. But this is something that we're really interested in. What is the journey of a CS Ed teacher? I'm at my time, so I won't go through this. These are some things that we still are interested in figuring out.
I built in extra time. Ha, I cheated.
Oh, okay. These are things that, you know, we have some ideas about, but we don't have, you know, really strong answers to at this moment. And things that have come up after having a school do this for 4 years. So a big thing is like, how do we help new students who may come in second or third grade who don't have the experience that the other students have? How do we onboard new teachers when all the teachers in the school have taught CS for 3 or 4 years, right? That's a big logistics problem. Another coach at Cornell Tech has also been exploring the idea that introducing computational thinking first creates a smoother on-ramp for teachers to then integrate computer science stuff once they're comfortable with CT. So that's another thing that, again, is currently we're researching. So again, now that you have all the context, here's the current draft. As I said, it's constantly being iterated on. And I will go back to this, but just wanted to thank you and give you my contact info if you're interested in more details. And then I'll go back to the scope and sequence while you have questions. Thank you.